Okay, good evening. Welcome to
MonsterMath69.
MonsterMath69. So this is something we're going to do together. So I saw something really neat on Twitter today, just kind of by accident, as I was driving home. Just as I was driving home.
Cool.
So our friends Nassim Taleb and Alexander Bogomolny were talking about what seems to be an incredibly complicated equation, and don't worry about how complicated it is. But it just was asking the question about this algebraic expression, x squared plus xy plus y squared times x squared plus xz plus z squared plus y squared times y squared plus yz plus z squared minus yz plus xz plus xy cubed. And the real question was about proving that this was always bigger than 0, as long as x, y, and z are bigger than 0, I think. But instead, I didn't follow the conversation, but instead Nassim Taleb was showing what it looked like when it was just a little bit bigger than 0. Oh, sorry, I wrote it backwards. Not bigger than, just a little bit bigger than 0, but less than 0.01. Okay?
Alright.
And it turned out that it was equal to this very amazing shape that I'm going to zoom in on here. Okay? Maybe I have to back the camera up just a little bit. Zoom in. Alright, so why don't you tell me what you see with that shape?
Well, it seems like it's symmetrical. That's threefold symmetry.
Oh, great thing to notice. Why do you think it's symmetrical?
Well, you have these sort of similar equations. You've got like these equations. I think they all multiply together to give you something.
Uh-huh. Yeah.
So sort of similar. Maybe that gives you the three folds.
Yeah, that's a great thing to notice, that there seems to be threefold symmetry, and you're absolutely right. That's coming from the fact that this equation itself has symmetry in x, y, and z. If I switched x and y, this wouldn't change. These two equations would flip, right?
Yeah.
And then what about this one here? If I switched x and y, what would happen?
It really wouldn't change that much.
Yeah, and so x and y and z can be flipped around without changing something, and that produces some threefold symmetry. So that's a neat thing to notice. So can you tell me something you noticed here?
Well,
Try to keep it in the square.
sort of. It comes together to be kind of right angles along here.
That's right, and that's going to be the x, y, and z axis when we look at the graph of it. Those are the axes. Yeah, but you're right. They do come together to form a right angle.
It looks like if we made this go on forever, it would go out to infinity. Like you have sort of like a half parabola shape.
Oh, where do you see a parabola?
Like here,
Oh,
part of it.
Very interesting.
Maybe if you extended it, the other part would go here.
Well, maybe that is a parabola. You know what? I don't know if it is or it isn't a parabola, but that's a neat thing to notice. Do you see anything else, or do you notice anything else?
Well, this curve here sort of looks like a circle curve.
Oh,
So if
interesting.
you added more, it would become a circle.
You think maybe it would become a circle, and your brother thinks maybe that it would become a parabola.
So I guess if you added 3 more, it would become sort of a square and then a circle cut out.
Yeah. So it's pretty neat. I really enjoyed looking at this, and then getting the 3D printer to be able to print it. I really enjoyed. And yeah, it all comes from this equation. So who would have thought that you could have an equation and get a really beautiful shape like that?
Cool.
You like it?
Yeah.
All right. Good job, guys.